Guys, a quick video series on arithmetic series, all right? Let's have a look at some of these questions, all right? Find the sum of the first 40 terms of this arithmetic series. First of all, the word arithmetic refers to a sequence where the jump between every term is exactly the same, okay? So you can see here, the jump between each term is 6. We call this an arithmetic series. It's because the jump is 6 every single time. A series means that we're going to be adding the terms together. So hence why it says find the sum of the first 40 terms of this arithmetic series. So how do we add these first 40 numbers? So 4 plus 10 plus 16 plus 22 plus 28 plus 34, etc., 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 until we hit the 40th number. Well, what we're going to be doing is we're going to be using this little formula. S is equal to n over 2 brackets 2a plus n minus 1d. Now over here, I've written down what each value means. S means the sum of the terms, n means the number of terms we're adding, a means the first term, n means the number of terms we're adding, and d is the difference between the terms, aka the common difference, all right? So whenever you're asked to add an arithmetic series, straight away I'm going to my formula sheet and copy out this formula, all right? Now just fill it in. So find the sum. So we're looking for the sum, so that will stay as s, and we're finding the sum of the first 40 terms. So the sum of the first 40 terms is equal to n. N means the number of terms. So if we have 40 terms, so 40 divided by 2, open brackets, 2 times a, 2 times the first term. Well, so it's going to be 2 times 4 plus n minus 1d. N means the number of terms, so 40 minus 1, and d is the difference between terms, which is 6. And we've plugged in all of our numbers, and we're just going to simplify slowly. So the sum of the first 40 terms is equal to 40 divided by 2 is 20. Open up our brackets. 2 times 4 is 8. Plus 40 minus 1 is 39. And then 6. Next, sum of the first 44 terms is equal to 20. 8 plus 39, 6 means 39 times 6, so 39 times 6 is 234. So the sum is equal to 20 times, we'll simplify 8 plus 234, 242. So the sum of the first 40 terms is equal to 20 times 242, which is 4,840. So the first 40 terms of this sequence add up to 4,840. That's it, guys. You're asked to find the sum of an arithmetic series. Just use the formula, plug in what you know, and see what comes out, all right? Easy as that. And you can try this question over here. Next question. I might have to copy out this formula. Add all the even numbers between 50 and 206. So we're finding the sum of a sequence, and we know it's arithmetic because it's all the even numbers. So 50, 52, 54. The jump every time is 2. So we can use this little formula over here because we're finding the sum of the sequence. So let's fill it out. So we're looking for the sum, and we know. Do we know the number of terms between 50 and 206? No, we don't know that yet. We don't know how many numbers are. We don't know how many even numbers there are between 50 and 206. So we'll skip that for now. So n over 2 bracket. So s, number of terms we don't know. 2 times a is the first term. Well, the first term is 50 and it's inclusive. So we're including 50 and 206. So 2 times 50 plus n minus 1. Well, we don't know the number of terms in our sequence, so n minus 1, d. The difference between each term is 2, because we're adding all the even numbers only. So 50, 52, 54, 56. The difference between each number is 2. So our d value is 2. All right, let's simplify this. So the sum of these terms is equal to n over 2, brackets, 2 times 50 is at 100, plus n minus 1, 2. Now, in order to find the sum, we have to find out n. We have to find out the number of terms in this sequence. Well, how do we do this? Well, in order to do this, guys, let's find out what the nth term is first. So our sequence is, let's draw a little table out, n and the value. So the first term is 50, the second term is 52, the third term is 54, the fourth term is 56. And if we're able to find out which term is 206, that will tell us how many terms there are, okay? Because 206 is the last term. If 206 is the 17th term, we know there are 17 terms in the sequence. So how do we do this? Well, step one, we'll find the nth term. So the jump is plus 2 every time. So it's going to be 2n. I'm going to replace n with 1. So 2 times 1 is 2, but I want 50. How do I get from 2 to 50? Well, I'm going to add 48. And that's our nth term, 2n plus 48. And what I'm going to do is I'm going to find out which term is 206. So what I'm going to do is I'm going to set my equation equal to 206 to find out which term 206 is. And I'll find n. So minus 48, boom, boom. 2n is equal to 206 minus 48, 158. Divide both sides by 2. N is equal to 79. So we know 206 is the 79th term. And if 206 is the last term, we know that there are 79 terms in the sequence. So we can replace n with 79. So the sum of the first 79 terms is equal to 79 over 2, brackets 100 plus 79 minus 1, 2. We'll simplify that is equal to 79 divided by 2 is, I think 39.5. Yes, 39.5. 100 plus 79 minus 1 is 78 times 2. 39.5. 100 plus 79 times 2 is 78 times 2 is 156. 39.5 times 100 plus 156 is 256. And now you're just going to multiply these numbers. 39.5 times 256. 10,112. And that is the sum of every even number between 50 and 206, okay? So I first realized that I need to add some sequences together. So I used my sequences formula. I filled in what I knew until I got to here. Then I realized I got to find out how many terms there are between 50 and 206. How many even numbers are there between 50 and 206? To do that, I found the nth term. And since I know, which it was 2n plus 48, since I know 206 was the last term, if I found out which term 206 is, that will tell me how many terms there are. So 206 was the 79th term. Therefore, there are 79 terms in this sequence. Let's move on to the next part. All right, next questions, guys. Just by the way, these questions in red are questions you can do by yourself, all right? So this question here and this question here. Now let's do this question here. Find the sum of the following arithmetic series. So we have a sequence. We're trying to find the sum. Therefore, we're going to definitely be using our little formula here, okay? So we're trying to find the sum of, we don't know how many terms are there yet. We're just finding the sum between 6 all the way to 106. So we don't know the number of terms yet. The number of terms over 2, brackets 2 times the first term, so 2 times 6. 2 times 6 plus n minus 1d. Well, we don't know how many terms there are in the sequence, so n minus 1. But we do know d. The difference between each term is 5. 5 every single time. Then we're just going to simplify. Sum of number of terms is equal to the number of terms over 2. 2 times 6 is 12, plus n minus 1, 5. So I realized in order to find the sum of this series, I have to find out the number of terms. Well, like before, to find out the number of terms, let's find out the nth term first. So we have our, let's make a little table, n and the value. So the first term is 6, the second term is 11. The third term is 16. The fourth term is 21. And then, if we're able to find out which term is 106, that will tell us how many terms there are in total, because it's the final term. So let's find the nth term first. So the jump is plus 5 every time. So it's definitely 5n. I'll replace n with 1. You can replace it with any number. Let's replace n with 4. So 5 times 4. So 5 times 4 is 20. But I want 21, so we're going to add 1. So our answer is going to be 5n plus 1. All right, then I want to find out which term gives us 106. So I'm going to set my equation equal to 106 and solve for n. So 5n, well, minus 1 on both sides. So 5n equals 105. And divide both sides by 5. N is equal to 21. So 106 is the 21st term in the sequence. And if it's the final term, therefore, there are 21 numbers in this sequence, all right? So n is 21. So the sum of the first 21 terms is equal to 21 over 2. 12 plus number of terms is 21 minus 1, 5. 21 divided by 2 is 10.5. 12 plus 20 times 5 is equal to 10.5. 12 plus 20 times 5 is 100. 100 plus 12 is 112. And we're just going to multiply these. 10.5 times 112. 1,176. And this is your answer, okay? Next one. The sum of the first 12 terms of an arithmetic series is 138. If the first term is negative 5, find the common difference. Okay, so I see a question about the sum of a sequence, an arithmetic sequence. We're definitely going to be using our formula. So let's get our formula out. And let's just plug it in. So let's have a look. S, the sum. Do we know the sum of the terms? Yes, the sum of the first 12 terms of an arithmetic series is 138. So we know the sum is 138. So 138 is equal to n. N is the number of terms, well, the sum of the first 12 terms. So n is 12 over 2. 2 times the first term. Well, the first term is negative 5. Plus n, the number of terms is 12. Minus 1. D. Do we know the difference between the terms? No. We just know that the first 112 term, we just know the first 12 terms add to 138, and the first term is negative 5. And we're actually trying to find the difference between the terms. So we're actually looking for D. That's our goal, to find the difference between each term. So we're trying to find D. Let's write it out and let's just simplify it. 138 is equal to 12 divided by 2 is 6. 2 times negative 5 is negative 10. Plus 12 minus 1 is 11D. So 138 equals, well, I'm going to expand the brackets. So 6 times negative 10 and 6 times 11D. So 6 times negative 10 is negative 60. 6 times 11D is 66D. So we're going to try and find D. So let's get D by itself. Well, first of all, D is being multiplied by 66, then subtracted by 60. So let's get rid of the 60 first. So the opposite of minus 60 is plus 60. Plus 60. 138 plus 60 is 198. This cancels out, so we're left with just 66D. D is being multiplied by 66, so we're going to divide 66. 198 divided by 66, I think it's 3. Yes, it is. So 3 is equal to, that cancels out, D. Cool. The common difference is 3. So first of all, guys, I saw I had a sum of a sequence. So I just used my formula, copied out what I knew. This time I knew the sum. I knew the number of terms. And I was looking for D. Then I just plugged in what I knew, simplified it, and I realized I could just use algebra to find what D was, all right? So you can try the next question over here. All right, boss. Let's do these two questions together, actually. I'll put this on the next page. All right. Last question. The 10th term of an arithmetic series is 66. The sum of the first 20 terms of S, which is our sequence, is 1290. Find the 5th term of S. So what do we know? We have an arithmetic series, and we know what the 10th term is, and we're looking for the 5th term. So let's just show a little table of this. So, boom, so n and the value. So we don't know what the first term is, we don't know what the second term is, third, fourth, fifth. We're looking for the 5th term. That's the goal of the question. We know the 10th term. We know the 10th term is 66. And we know that the sum of the first 20 terms adds up to 1290. Alright, so how can we use this information to find the 5th term? Well, since we know the sum of a sequence, it's always just best to use your formula, your sum of series formula, okay? So if you don't know what to do, but you see something about a sequence and we're adding the sequence together, just use your sequence, the sum of series formula, and just plug in the blanks. So we know that the sum of the first 20 terms is 1290. So S is 1290 is equal to N. N is the number of terms. Well, the first 20 terms add to 1290. 2 times A. A is the first term. Well, we don't know what the first term is, so just 2A. Plus N. Well, we added up 20 terms. Minus 1. D. Do we know the difference between each term? No, we don't. So it stays as D. Let's simplify that. So 1290 equals 20 divided by 2 is 10. 2A plus 20 minus 1 is 19D. Let's expand the brackets because I see some brackets. So 10 times 2A is 20A. 10 times 19D is plus 19D. Cool. So we've created this sort of expression, okay? Now, we've pretty much dealt with this sentence here. Now let's deal with the first sentence. The 10th term of an arithmetic series is 66. Now guys, there's a little formula you can use. It's not on your formula sheet for the nth term, okay? And you can use this formula to just help you plug in some numbers and maybe we can create something, all right? So we call this the nth term formula. A plus n minus 1d. A is just the same thing, the first term. N is the number of terms. D is the difference between the terms, and V is the value of the term, all right? So we know the 10th term is 66. So we can plug this information into this formula here. So A is the first term. Well, we don't know what the first term is, so A stays like A plus N. Well, we know this is the 10th term. We know the 10th term minus 1. The difference between each term we don't know, so we'll label it as D. And we know the 10th term gives us a value of 66. Cool. So we've created this. Let's expand this brackets and let's simplify this. So A plus 10 minus 1 is 9D equals 66. So we have this equation here and this equation here. Holy crap. We have created simultaneous equations. Our first equation is A plus 9D equals 66. And our second equation is, let's put the 20A plus 19D in front. 20A plus 19D equals 1290. We've created simultaneous equations. Let's solve the simultaneous equations. Remember, to solve simultaneous equations, before you eliminate something, make sure the A's or the D's are the same. So I can make the A's the same by multiplying this A by 20. If I multiply this A by 20, I'll make 20A, so I can eliminate it from this 20A. So I'm going to multiply the top expression by 20. So A times 20 is 20A, plus 9D times 20 is 180D, and then 66 times 20 is 1320. And the bottom stays the same, so 20A plus 19D equals 1290. Now, how can I eliminate the 20a's? Well, I can subtract them. So we're using the elimination method of some simultaneous equations. So we want to get rid of the a's. So 20a minus 20a. So 20a minus 20a is nothing. That just disappears. Then it's 180d minus 19d, which is 161d. And then 1320 minus 1290 is 30. So d is equal to 30 divided by 161. I've made a mistake somewhere, haven't I? Oh, yes, here's my mistake. 10 times 19 is 190, not 19. So 190d. So $28 plus 190d plus 190d. $190d, 190d. So 10d minus 190d is negative 10d. And 1320 minus 1290 is 30. So d is being multiplied by negative 10. So I'm going to divide both sides by negative 10 to give me d. D is negative 3. So we know the difference between each term is negative 3. So every time we're going minus 3, minus 3, minus 3. So if we know what the 10th term is 66, let's go backwards by adding 3. So 66 plus 3, plus 3, plus 3, plus 3, plus 3. So 66 plus 3 is 69, 72, 75, 78, 81. And that is our answer for this question. The fifth term is 81. All right, and we're all done for this video, guys. Here's a past paper question, a little bit tricky. In an arithmetic series, the sixth term is 39. In the same arithmetic series, the 19th term is 7.8. Work out the sum of the first 25 terms of the arithmetic series. So I'm being asked to find the sum of a series, arithmetic series. So I'm definitely going to be using our formula. So let's get our formula out and just plug in the blanks. So we're trying to find the sum of the first 25 terms. So n is the number of terms. Well, we're going to add the first 25 terms. So 25 over 2, open brackets, 2 times a. A is the first term. Well, in this sequence, we only know the 6th term and the 19th term. So we don't know what a is yet. So 2a plus n. Well, n is the number of terms. Well, we're adding the first 25 terms. Minus 1d, the difference between each term. Well, we only know the 6th term and the 19th term, so we don't actually know the difference between each term. So d. Let's just simplify this. 25 divided by 2 is 12.5. 2a plus 25 minus 1 is 24d. So now we look at our formula and realize we need to find out what the value of a is and the value of d. So we got to find out what the first term in our sequence is, and we got to find out what the difference between each term is. So I've completely neglected this first part here, so maybe this part will help us. So we have a sequence or a series, and it's arithmetic. Remember, guys, an arithmetic series or sequence is a sequence where the jump between each number is the same every time. So let's just draw a little table over here. So n and v. We don't know what the first term is. We don't know what the second term is. Third, fourth, fifth, sixth. We know the 6th term is 39. We don't know what the 7th term is. But we do know, what the 19th term is. We know the 19th term is 7.8. So I've drawn this just to help us illustrate it in this table. So Now we know it's an arithmetic sequence. Arithmetic means the jump between each number is the same every time. So the jump from the 6th term to the 7th term is plus x. Therefore, the jump from the 7th term to the 8th term is plus x as well. 8th to 9th is plus x. So what I think to myself is, how many jumps are there between the 6th term and the 19th term? Well, from 6 to 19, there are 13 jumps. And since it's an arithmetic sequence, so 6 to 19 is 13 jumps. So 1, 2, let's have a double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yep, there's 13 jumps between the 6th term and the 19th term. And it's arithmetic, so we're all equal jumps. So 13 equal jumps. And we know the jump from 39 to 7.8 is 39 to 7.8. So I'm just going to do 39 minus 7.8. That's what I'm going to do here. The gap between these two numbers, the difference between these two numbers is 31.2. So the jump from 39 to 7.8 is minus 31.2 because we're going backwards. So what we can do is we can split negative 31.2 into 13 equal jumps. So we can do negative 31.2 divide by 13. Divide that by 13 is 2.4 or negative 2.4. So we know each jump is minus 2.4. From the 7th to the 8th term is minus 2.4. So that's the difference between each term. And D stands for the difference between each term. So now we can fill out our D value. Our D value is negative 2.4. So 24 times negative 2.4. Now we got to find the first term. Well, we know that the jump between every single term is negative 2.4. So our first term, minus 2.4, minus 2.4. Actually, no. So now basically, if we want to go backwards, so to go forwards, we minus 2.4. To go backwards, we're going to add 2.4. So to get from the 6th to the 5th term, we're going to add 2.4. Then add 2.4. Then add 2.4. Then add 2.4. Then add 2.4. So 39. Let's find the 5th term. So 39 plus 2.4 is 41.4. Then add 2.4 will give us the 4th term. 43.4. 43.8, sorry. And we're just going to keep on adding 2.4 till we get to the first term. So plus 2.4, that's the 3rd term, 2nd term, 3rd term. The first term is 51, all right? So now we know our A value. It's going to be 51. So the sum of the first 25 terms is equal to 12.5. 2 times A is the first term, which is 51, plus 24 times negative 2.4. So that's equal to 12.5. 2 times 51 is 102, plus, oh no, we don't know it's plus yet. 24 times negative 2.4 is negative 57.6. Let's simplify the bracket. So 102 minus 57.6 is 44.4. And we're going to multiply this. So 44.4 times 12.5 is 555. And this is how you solve this question, right? The same thing, we used our formula. We filled in what we knew. Then we realized that we're missing the A and the D value. To find the A and the D value, so the first term and the difference between each term, we use this information here. And I knew the 6th term and the 19th term. So between 6 and 19, there's 13 jumps. And from 39 to 7.8, we went backwards 31.2. So we split 31.2 into 13 jumps by dividing them, which gave us minus 2.4. So that was the difference between each term, minus 2.4. Then to find the first term, we just added 2.4 until we went back to the first term, which gave us 51. We just put it back into our formula and we solved it. Let's try the final problem.